Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is Enhance Application Speed and Scalability with Oracle's Managed Valkey, which will cover an introduction to Valkey, OCI Cache Service Overview, some key features, and a demonstration. I'd like to introduce Dimitri and Rashmi as the main presenters, and with that, I will hand it over to you, Rashmi.
Thank you, Olivia. Hi, everyone. Good morning, good afternoon, good evening, wherever you are, and welcome to this session on OCI Cache. I am the product manager for OCI Cache, and I'm joined by with Dmitry Polyakowski, who is our technical lead for the service. So moving on, as a safe harbor, if there are any announcements or mention of future releases, then this is a safe harbor statement. What we will be covering today, I'll go over an introduction to the OCI Cache service, some of the key features of the service, a couple of customer success stories, and then Dimitri will get into a technical deep dive demo where he will demonstrate the features and the service itself. But before I speak about OCI Cache, let's understand, why do you need a cache? Consider your cloud scale applications, right? Be it gaming, social media, e-commerce, finance. If you have users who are on high-speed network, but the responses for the applications are really slow, that's really bad user experience, right? That can be frustrating for your end users. So the response time is very critical there. And if you have your applications having to query the database time and again, even when the data is not changing, that's just overloading your database, not to say the least, the network congestion that it causes. So these are some of the challenges that a cache tries to address. It helps maintain frequently accessed data in a cache, in a in-memory data store, where response times are sub-milliseconds. So your end user sees super fast responses. That is a better user experience for the consumers of your application. It reduces load on the database because most of the frequently used data that is not changing lives in the cache. So your database can cater to write requests and other workloads. And your network congestion is reduced because there's no back and forth traffic going between the application and the backend stores, right? That's how a cache would help. And caches can be in-memory data stores, but they have other use cases like session management, geospatial indexing, and such. So what are your options for a cache? A cache there are various types of caches. There can be local caches, there are distributed caches, there are caches within your application. Each one has its own strengths and weaknesses. For a cloud scale application, one would consider a distributed cache, right? And these are caches that need to be scalable, they need to be performant, they need to be highly available. These are non-negotiable factors for a distributed cache. Focusing on a couple of well-known and popular distributed cache offerings out there, Valkey and Redis. These caches support various use cases. Like I said, frequently accessed data is one of the use cases, but they also can be used for rate limiting, session management. We have customers using that, real-time analytics, your gaming, so that your multi-game experience is smooth and quick. To support these use cases, these Valkey and Redis support various data structures. They can be strings, simple key value pairs. They can be really large values. They can be as big as multiple KBs of JSON structure, hashes, lists, sets. These are the data structures that these caching options provide to support the various use cases that are available today. So you can spin up a cluster of Valkey or Redis in your architecture and derive the strengths of those by super fast response times. Well, when I say you can launch a cluster, but it comes with its own set of challenges, right? You have to make sure that you are making that cluster highly available. You have to maintain the cluster. You have to make sure that software updates are applied to it, security fixes are applied to it. You should be able to scale it up and down based on your workload, monitor the health of the cluster itself. These are complex tasks. Some of them are routine tasks, and this can get really tedious. You don't want your team to focus on operational things like this when they can spend that time on the business itself, right? And this is where you would benefit from a managed service like OCI Cache. So OCI Cache is a fully managed distributed caching service. We support Valkey 7.2 and Redis 7.0 in our service. Valkey 7.2 is in limited availability right now. The service itself was launched in October 2023. It's available in all of the OCI regions. The OCI cache is compatible with Redis and Valkey. So if you have applications using these caches today, you can migrate it pretty much without any changes to your application to OCI cache and get started. So the deployment and maintenance of your clusters is taken care of. The routine tasks of patching, upgrading, updates is taken care of. High availability is taken care of. So you can focus on your business applications. And because this is an OCI native service, it leverages from the strength of the underlying platform. Highly secure, scalable. Security is the most important thing for OCI as a platform, right? Highly available because we have multi-AD regions, fault domains within the regions. So you can have a caching service that's fully maintained for you, and all you have to do is spin off the cluster. Speaking a little more about Valkey. Now, in March of last year, Redis Labs made a few changes to their licensing, which prevented any version of Redis beyond 7.2 from being used in a service by a cloud provider. So a bunch of leading cloud providers, including Oracle, they backed an effort by Linux Foundation called the Valkey project. And Valkey is essentially a fork of Redis 7.2. And we at OCI Cache also support and provide Valkey 7.2 as a caching engine. You are able to spin off a Valkey cluster in our service. I repeat, this is in limited availability right now. Get in touch with your Oracle support or raise an SR, and we are happy to help you access the Valkey engine in our service. So with Valkey, why would you use Valkey, right? Let's see what's special about it. This is a slide that I've put up, but I know that Dimitri will go into greater detail about the values of Valkey during his demonstration. But like I said, Redis Labs restricted the use of its software. And so Valkey is something that is backed by Linux Foundation. It is truly open source. We have a vast open source community that is committed to advancing and adding more and more features to Valkey. It is more efficient. It is more secure with the latest security fixes being applied to it so that all the CVEs are addressed. It has various features that are improving its performance, standardizing some of the client libraries so that your applications are using a standard client. And there are various modules that Redis supports, which Valkey also does support. And this list is just going to grow more and more. So Valkey is one of the many open source software projects that Oracle supports. OCI and Oracle are committed to open source. And the slide shows you a list of services that are based on various open source software out there. OCI Cache offers Redis, the open source version of Redis, and now Valkey in limited availability. Okay. At this point, I'll go over the key features very quickly of the service itself, and Dimitri will demonstrate each of these features during his deep dive demo. So OCI Cache is a fully managed service, which means your cluster creation is as simple as making a few simple choices and the click of a button. Your cluster is provisioned for you in a few minutes. You do not have to worry about your OS level patching. You do not have to worry about the metrics you need to make available to monitor the health of a cluster. You do not have to worry about automatic failover. With the right configuration of the cluster, the failover will happen automatically for you. If you have a single node, then it takes a couple of minutes for a new node to be provisioned to failover automatically. Or if you have your cluster set up in an HA kind of configuration where you have more than 2 nodes, then the failover is much more faster. So it's zero data loss, nearly real time if you have the right cluster configuration. And with the right cluster configuration, you also get an SLA of 99.95%. Choosing the configuration of the cluster itself is very simple. You can just pick the number of nodes you want in your cluster, the memory, which is the primary factor in a cache that you want in the cluster, and you are able to provision exactly the amount of memory that your workload needs. You do not need to plan ahead and over provision, so you pay for only what you use there. But if your workload changes, if it goes up or it goes down, then you are also able to scale your cluster. You can scale the number of nodes. You can scale the memory within the nodes. Memory can vary from 2 GB to 500 GB. You can shard your cluster if you think that your workload needs more memory or better performance. You can choose sharded clusters of up to 100 nodes. Within your sharded cluster, you can have replicas of up to 5 nodes for each shard. So you can scale it up and down based on your workload, right? So you're using exactly what you need. Monitoring the cluster and its cluster health is also important. So we provide out-of-the-box metrics for you to monitor that cluster and its health. You can check the CPU utilization, the memory utilization. You are able to set alarms at certain thresholds, lower or higher thresholds of these metrics, so that you can take action based on that, whether you want to resize your cluster. You're also able to monitor the network bytes in and out of the cluster. So all this helps you see how optimally the cluster is being utilized, and then adjust it based on your use case. OCI as a platform supports high availability. We have regions that are multi-AD, that is availability domains. If it is a single AD, then within that also we have multiple fault domains. So when you provision a cluster with more than 1 nodes, that is if you have a primary and 1 or more replica nodes in the cluster, we make sure that in a multi-AD region, those nodes are across ADs. And if it's a single AD region, then we make sure that they are across the fault domains. So HA is taken care of by leveraging the inherent OCI platform and its capabilities. So with these features, then how do you get started with OCI Cache? Like I said, it's pretty simple to spin off a cluster. You will need to set up a couple of mandatory IAM policies to start the cluster. You have to give a manage kind of privilege to a certain user or group that is responsible to set up the cluster. There is one policy that will help create a private endpoint so that your applications can connect to the nodes of the cluster. There are a couple of optional policies that you can set to help create a new VCN or subnet during the creation of the cluster. And we can also help create a security list that is specific to the Redis cluster within your security list definitions. But this is optional. You can choose to do it yourself if you do not want our service to set it for you. This is essential to manage the security of your cluster so that the right access permissions are granted. Once you've set the policies, then your user would go to create a cluster. They would pick either Valkey or Redis, whichever one they want to set up the cluster with. They would choose if they want a sharded or non-sharded cluster. They would pick the nodes. The number of nodes would be your primary plus replicas. They would pick the memory within the node. And it's as simple as that. You hit create and your cluster gets created in a matter of minutes and you're ready to go. So if you have a non-sharded cluster, then we have a single read endpoint, and Dimitri will go over all of these in great detail. You have a single read endpoint, and your applications can connect to that read endpoint. In a in a sharded cluster, you have a list of primary nodes that you would use to connect to the cluster. And all the common clients like Redis and Lettuce are supported with OCI Cache as well. So like I said, it's fairly simple. We are fully compatible with Redis and Valkey. You will be able to migrate your applications with almost no changes to the application to move to OCI Cache. We have a large number of customers using OCI Cache. I'll just mention a couple of them. Corpor is a leading supply chain automation solution. They are one of the customers who use OCI Cache not to front a database, but for their session management and to cache their API data. They wanted to migrate from their on-premise and AWS warehouse management system that was hosted on AWS and on-prem. To them, I think the flexibility, efficiency, scalability, and cost were the main attractions for OCI. After migrating to OCI, which was very quick implementation of a matter of days, they managed to achieve about 50% cost savings and about 40% of performance improvement over their on-prem applications. They are able to cater to their customers' businesses based on the changing seasons, right? For example, a Black Friday sale, they are able to scale up to meet the increase in demand for the whole pipeline of supply chain from the warehouse right up to the last mile connectivity. So that's Corpor's usage of OCI Cache. They use it in addition. They also use the Kubernetes and Postgres services in OCI. Seismic is another customer that is a sales enablement platform. They have been using OCI Cache along with Postgres. They have a large deployment of OCI cluster. It says 230 here, but I think it's way beyond 230 already, the number of clusters that they have for cache. They also have a very wide Postgres footprint in OCI. They help. Again, the flexibility is an important factor for them. They're able to scale up and down based on their customer needs. And the response times and latency are handled so well that their end users, the consumers of the sales enablement platforms, their user experience has improved to a great extent after the use of OCI Cache with Postgres. With that, I will hand it over to Dimitri for a deep dive demo.
Hello, my name is Dmitry Polikovsky. I'm a tech lead for the OCI Cache Service, and here I'm going to do a deep dive on the OCI Cache Service. But first, looking at the survey results, I see a lot of folks not super familiar with Redis and Valkey, so I'll talk briefly about that. So Redis started about 15 years ago by an engineer named Salvatore Sanfilippo, who needed an open source high performance in-memory database. So he open sourced it eventually, and later a company formed around it, which was known as Redis Labs or Redis Inc. And what Redis is, it's a memory database, but it does have a cool feature that it can persist data to disk in the background. And it offers very powerful data structures. For example, the most popular data structures are strings, lists, hash maps, sets, and sorted sets. And what it allows you to do is it also allows you to set expiration or time to live, TTL, on each individual key. So that's a great use case for caching. So you can basically say like set foo bar, and it'll hold that key forever. And then you can say, set expiration on that key. So one key can expire in 5 minutes, another key can expire in 5 hours. And that's a great use case where your application doesn't have to worry about when the data has to be purged. Redis will take care of it for you. OCI Cache is a managed Redis service. So we basically take care of all the DevOps challenges so you can focus on building new applications. And it actually not only saves you valuable engineering time, but it also saves you money by enabling to right-size your cache infrastructure. When you create your own infrastructure, you manage your own servers, you often end up over-provisioning them, and that basically wastes money. So Redis OCI Cache G8 in the fall of 2023, and we offer open source Redis 7.0. And currently we are in LA, or limited availability of Valkey 7.2. Now we will still continue supporting Redis 7.0 for foreseeable future, so you can use either engine with us. And we offer open source software, and we allow you to use any of the features of it, the underlying software. And the only thing we restrict are very few administrative commands that we need to control to ensure the cluster stability. And that is very similar to other cloud providers. So let's go to the demo. So here you can see that I'm logged into Oracle Cloud Console. And this is an Abu Dhabi region, but the same functionality is available in all of our other regions. So I'm going to specify a name, demo. I'll pick a compartment, and then I'll specify the Redis or cache engine version. Let's say I do want to go with Redis 7.0. And we kind of warn you that we recommend Valkey 7.2, but we still give you a choice. This is a cluster configuration screen. So the most important thing, you have to decide whether you're going to be writing sharded or non-sharded clusters, or what Redis calls cluster mode. Now, in a sharded or cluster mode, data is split across multiple shards. So here, for example, I'm going to create 3 shards. Each one is going to have 16 gigabytes of RAM. So this way I can store a total of 48 gigs of memory. But I'm also specifying 2 additional nodes per shard, which will act as replicas. And you want replicas to ensure system stability, because if anything happens to the primary node of the shard, you don't want to lose data. Well, since there are replicas in this case, what's going to happen is that our monitoring system will kick in, and in a matter of seconds, it's going to take one of these replicas and promote it to be a primary. And then our system will give the node time to recover. If it doesn't recover, we will actually replace the server behind the scenes. We will add it to the cluster in appropriate role and set up all the replication monitoring, so you will have no downtime to your application, as long as you implement proper connection pooling, because when all these things happen in the background, connections can be lost. And this connection pooling is very important for other reasons as well, because you can have a network glitch. So make sure you're using a modern Redis library that supports proper connection pooling and reconnection. But maybe you don't need sharding. So in this case, we support non-sharded or just regular Redis. So in this case, I'm specifying 3 nodes, and I'm specifying 16 gigabytes of memory per node. So I can only store 16 gigs total in each. Well, in this case, it's only one primary or master server, and it'll have 2 standby replicas. So we can explain it to you all here. Now, this is a decision you have to make during the cluster creation, because you cannot switch from one mode to another. Everything else, for example, in changing nodes, memory, or changing the number of shards on a sharded cluster, you can resize later after the cluster creation, and it will be a no downtime resize operation. So your application will not be impacted as long as you implement proper connection pooling. So let's say we want to go just with a non-sharded cluster, and let's say we want 16 gigs. This is a standard OCI network configuration dialog. We can choose an existing VCN and subnet, or we can choose to create a new one. In order to connect to the Redis cluster, you need to be either in the same VCN, or you have to set up appropriate route rules. So here, to keep things simple, I will just use our existing consumer subnet. We optionally support network security groups. So you can add a few network security groups here, up to 5. So this is a standard screen where you're just kind of like going to review your configuration. Again, we're going with Redis 7.0 for 3 nodes, non-sharded, 16 gigs, and we're going to click Create Cluster. Now, to save time, I pre-created a few clusters here. So this is a Redis non-sharded cluster. And what can we do here? Well, let's say we do want to resize memory. Let's say we want to go from 2 gigs of memory to 3 gigs of memory. This is going to be, as I said, no downtime operation, but there may be some performance impact, because what we're going to do behind the scenes is we're going to take one of the nodes, take one of the replica nodes, and increase its size, which requires a reboot. So we do it one at a time. So first we're going to do this node, then we're going to do this node, and the very last thing we will do is the primary node. And to do that, we're going to, again, take one of the replicas and explicitly promote it to be the primary. So this is going to be a very, very tiny fraction of a second blip where this operation happens. And as I said earlier, if you implement proper connection pooling, you will have no problems. But after all of this is done, in a matter of minutes, you will have 3 gigs of memory per node versus only 2. Let's go to another node here. This is a Redis sharded. Okay. Again, we're kind of warning you here that you only have 1 or 2 nodes. And the reason here this warning appears is because it's 1 or 2 nodes per per shard. So you can see here that it's 6 nodes in a configuration of 3 shards, with each shard containing only 2 nodes. So this gives you one level of redundancy within each shard. And if one of the replicas or primaries crashes, as I said earlier, within seconds, our monitoring will kick in. But it's less resilient than having 2 replicas per shard. So let's say we want to make our cluster more resilient here. So we're going to say, let's resize nodes. So we're going to go from 2 nodes per shard to 3 nodes per shard. So what's going to happen here is that we will launch additional servers. In this case, it's going to be 3 servers. And we will add them to the cluster. And we will make them replicas of each shard. And as I said before, you don't have to change any of your code. All these servers will be automatically added. And what sharded clusters do is that there's a concept of a topology. And you can connect to any of the nodes in the cluster. And it'll send you the topology, meaning all of the other nodes. And with sharding, the writes will occur to all the primaries. And the reads will occur to from the replicas. Very often, it depends on the library, actually. But very often, that's how the libraries do it. And that really enables you to scale. All right, so while we're resizing this sharded cluster, let's go to another screen here. So this is a Valkey sharded cluster. Again, it's giving us the same warning as because we only have 2 nodes per shard here. But let's talk more about that thing I mentioned earlier. How do we connect to this cluster? So what we recommend is that while you do have 6 nodes, 6 endpoints here, you probably don't want to put all 6 of these endpoints in your application. And you don't have to. You can put as little as 1 of these endpoints. And then your application on startup, if it's using one of the more recent Redis sharded cluster or libraries, will connect to this node and discover the full topology, as I mentioned earlier. However, that does present a little bit of a potential single point of failure in your application. So what happens if during the application startup, this particular server may be down? Your application will not be able to connect to the server, and therefore it will not be able to connect to discover the cluster topology, even though the other nodes in a cluster are perfectly fine. So what we recommend is you take the first 3 shards, which is a minimum configuration. We require you to have at least 3 shards. And you take the first node within the shard. So this is 1.1, 2.1, and 3.1. And all of this is documented on our public website, by the way. But this way, you have triple resiliency. So if, let's say, this server happens to be down at this time, well, your application will just connect to this server or this server. And while this server is being recovered, the monitoring, like I said, in a matter of minutes, it will actually replace the server. But you can have a very low probability of outage on a specific server. Again, there's just simply nothing we can do about things like hardware failure. But we do work very hard to ensure that it has a minimum impact on your applications. Now, in case of non-sharded cluster, I want to talk about connectivity a little bit. So non-sharded or regular Redis clusters work differently. So you don't have a concept of topology discovery. What you do instead is you have one server that's write, which we'll call the primary or master, and you have other servers that are read-only. So what you have here is these different endpoints. We call it primary endpoint and replicas endpoint. And in this case, you're going to perform all your writes here, and you can perform all your reads here from this URL. Now, since it's a 3-node cluster, we can guess that there are 2 servers behind the replicas endpoint and 1 server behind this endpoint. And we guarantee that there is always going to be at least 1 writable server here and at least 1 writable server here, because it is possible that one of the replicas will fail, or even the primary will fail. But like I said, our monitoring kicks in a matter of seconds. Okay, let's say we do want to resize this cluster. So let's say we did the resize memory here operation. We did resize shards. Oh no, let's actually resize shards. So let's say in a sharded cluster, we want to increase the overall capacity of our cluster, but we don't want to store more data per shard. We want to have more shards. So we can go from 3 shards to 5. And each shard is still going to have 2 nodes. So this is going to be, again, another node downtime operation. But what we will do is we will launch 4 additional servers, because those will be shard 4 and shard 5. And each shard will have 2 servers in it. After we launch these servers, we're going to actually add them to the cluster, and then we'll copy data for you. So basically, each of these shards, 1, 2, and 3, will share a portion of its data set. So if you have, let's say, 50 gigs of data per shard, And let's say they're not just in the size of the cluster, but let's say each shard is actually storing 50 gigs of data. In 3 shards, 50 gigs, but when it's done resizing it, you will have 5 shards and each shard will store 30 gigs. Now, why would you want to do that? Why not just scale vertically and simply store more data per shard? Well, first of all, there's a limit to how much you can scale vertically. We support up to a maximum of 500 gigs of data per single node, or in this case, shard. But if in case you need to store more data, you could, like I said, increase shards. So if you have, let's say, you had a very large cluster with 3 shards, and each shard was storing 500 gigs, that would be a limit. But you can go to 5 shards, and then each shard would only need to store 300 gigs. Or you could store 5 shards with 500 gigs. So think of it as like a third dimension when it comes to scaling your application. So you can scale it vertically by increasing memory. You can scale it horizontally by increasing shards in the cluster. And again, that applies only to sharded clusters. And then the resizing nodes, it doesn't allow you to store more data, but it improves your overall resiliency. Having at least 1 replica per shard, meaning 2 nodes per shard, is what you want for a mission-critical system. All right, so this is resizing the cluster. Again, this is a very small cluster. I only have 2 gigs. You probably wouldn't want to make it a 5-shard cluster, but your application is going to work exactly the same. So if in production, let's say you have a very large system and you need to store hundreds of gigs of data, you can say, well, I'm going to have multiple shards, and you have to ask yourself a question: is my application going to be very write-heavy or read-heavy? And that's an important decision in right-sizing your cluster, because if you have a more write-heavy application, then you do want to have more shards, because the number of writes will be proportional to the number of shards you have. The more shards, the more data you can write. However, the number of reads will be proportional to the total number of nodes, because read operations can be done from replicas. So ask yourself a question: do I want more shards for more writes, or do I want more nodes per shard if I need to have more reads? And that, again, we cannot make the decision for you, but we give you the tools to do that. Okay, let's see. Oh, I want to talk about metrics. So here's another cluster I have. This is a Valkey non-sharded cluster. So we have all the standard OCI functionality. For example, here is work requests, but this is the screen that I want to focus on. This is metrics. We expose 12 different metrics, 4 operating system level metrics, such as CPU, memory, network traffic in and out. But to me, the most important metric is this one, used memory. So this is what you want to build an alarm on, and we support standard OCI alarms here. You can basically just click this, and you'll be able to build an alarm and get notifications. But what you want to be alerted at a certain point. Let's say if you're 70 or 80% full, and once you're alerted, your engineers can make a decision. Do we want to resize this cluster? Probably yes. So you get an alert and you say, oh, I want to resize my cluster. And let's say you want to go from 2 gigs of memory to 3 gigs. So again, you just click this, and within a matter of minutes, you will have another cluster. You would have updated your cluster. But again, I want to emphasize, all the connection strings will still remain the same. So you do not have to change your code. Again, your developers don't need to do anything, but your DevOps engineers or SREs will be able to handle it all via updating the cluster either via the console, or you can also use CLI, Terraform, SDK, where we support all of the standard OCI features. Let's see, we talked about metrics. Let's briefly touch on network security groups. So as I mentioned earlier, you can use network security groups to control access to your cluster, and that can be done either during cluster creation or afterwards. So here's where you would see how to configure network security groups, and you would add in your network security groups, which gives you a more granular way to control access. So if you have a very large VCN used by different applications, you may create a cluster, and then say this cluster will be only accessible from NSG1, but it will not be accessible from other network security groups within your VCN. Let's see if the demo is finished. Okay, oh yep, it is. So it took a few minutes. So now let's see, we created this as a Redis 7.0 cluster. Let's say we want to upgrade. That can be done either from here, or it's also one of the actions can be accessed here, but we wanted to make it a little bit more prominent. Either way, it'll take you to the same screen. So here's where we tell you what's going to happen. That after you upgrade from Redis 7.0 to Valkey 7.2, you will not be able to come back. So we tell you explicitly. So please test your code carefully. Redis 7.2 is fully compatible with Redis 7.0 is fully compatible with Valkey 7.2. However, you never know what your application might be doing. However, during the upgrade, what we actually do is we launch new servers and we replicate the data. And once the replication completes to the new servers from Redis to Valkey, which is again fully supported by the open source technology, we then basically validate the replication happened successfully and we throw away the old servers. So if there are any problems that happen during this process, we will actually roll back automatically. However, once we determine that the upgrade successfully completed and we throw away your old servers, you cannot go back. So let's do an upgrade. Okay, let's see. Rashmi, is there anything else you wanted me to cover? I think that's about it for my demo. We talked about sharding and not sharded. We talked about Valkey versus Redis. We talked about all the standard OCI features such as compartment and VCNs and NSGs. We talked about ability to resize clusters without any downtime. However, again, I just want to emphasize that there may be a performance impact to your cluster during the resize operation. And we talked about metrics.
To just highlight some of the Valkey benefits.
Oh, okay. Absolutely. Thank you. So, okay. So look, it's a good question. So if you're using Redis, why should you consider Valkey? Well, Redis, again, great technology. I've used it myself for many years, but personally, I'm pretty excited about the Valkey project because Valkey is a little bit more free. So it's an open source project under the umbrella of Linux Foundation. And Redis was controlled by Redis, the company, and they were also obviously were trying to sell their commercial product. And some of the features in Redis 7, Redis 7.0 or Redis 7.2 just weren't as good as they could have been, in my opinion. So basically, under Valkey umbrella, there's a lot more flexibility. So Valkey project is, again, all the information is available on Valkey.io website. And there's a really cool improvements. There's primarily then Valkey 8, which we do plan to offer in the future. Cannot speak to the dates. But for example, Valkey 8 allows you to use 1 million requests per second. That's a very interesting development. And what they did behind the scenes, they actually introduced certain multi-threading features. That's how they're able to increase their requests per second so drastically. The Valkey 7.2 is a much more kind of feature compatible upgrade. So Redis 7.2 is essentially Valkey 7.2. And we decided to first introduce Valkey 7.2 to simply kind of make it a more gradual upgrade process. If you're writing Redis 7.0, it's safer to go directly to Valkey 7.2 and make sure your application still works properly, and later upgrade to Valkey 8 once OCI offers Valkey 8 and future releases. So if you're interested in Valkey, check out its website, valkey.io. Lots of really good information. Or if you're interested, you can go to GitHub and just read about their project. They're very open about it. You can see all of their repositories. They're offering a lot of very cool features. For example, there's these modules called Valkey Search and Valkey JSON, and that's a very interesting it gives you a very interesting ability to extend Redis or Valkey beyond its core cache use case, but ability to store JSON is a very powerful extension.
Can you talk a little bit about the modules that Valkey will offer?
Oh, of course. Yeah. So Redis on its own actually has supported module for almost 8 years, and module is ability to extend Redis core functionality with certain additional features. For example, Redis has hash maps, but it doesn't support JSON. So Redis built a JSON module. However, the licensing of that module didn't allow cloud vendors to offer it as a service. So some of them actually were building their own modules. So the two most popular modules that existed for Redis are Redis Search and Redis JSON. And the umbrella of the Valkey project, they're now equivalent. They're different modules, different code. However, they're 100% API compatible with the Redis versions. So for example, if you're using Redis JSON module, which you can use, you can either use it as part of the Redis Enterprise if you had that license, or even if you were just running your own open source Redis, you could run that module. However, Valkey JSON module is licensed in a way that we can offer it as part of the cloud service. It's BSD3 license versus some of the more restrictive licenses. So for example, if you want to use Valkey JSON, again, once your cloud provider is offering it, and OCI, we are looking into offering these modules, you will be able to not just store hash maps or strings or lists, but you can store full-blown JSON documents in Valkey. And that's a very powerful feature because often you end up taking a very complex object and serializing it to a string, storing it in Redis as a string. And then when you have to make a small change to the entire JSON structure, you have to extract the entire JSON, you have to extract the entire string from Redis or Valkey, convert it back to JSON, make the change, and then write the whole thing back to Valkey. Well, that is a huge performance bottleneck. It can be a huge performance bottleneck because you have to read and write a lot of data. It can impact your network traffic and so on. So with JSON, you can update only one of the attributes inside the JSON document. And then if you combine it with a search module, you can literally introduce secondary indexes, and you can essentially do full searches, full queries on this. And the other thing that Valkey search module can be used for is for vector similarity search. So that is a very important part of AI and ML workloads. All right. I don't think I have anything else.
Yeah, let me quickly add another comment.
Of course.
So, we are very excited to be part of the open source Valkey community. Oracle and OCI, we were, one of the founding members of this exciting new project. This project is now under the umbrella of Linux Foundation, and we are collaborating with other hyperscalers, including AWS and Google Cloud Platform. So we are very excited to be part of the community and help innovate and bring those innovations back to the OCI customers through OCI Cache. Having said that, our commitment to our existing customers who are using the Redis engine within OCI Cache does not change. Those clusters will continue operating. People and customers can launch new Redis clusters as well. We encourage people to move to Valkey because of all the new innovations that Dimitri talked about. But if some users want to take their time before they decide to upgrade to Valkey, or for whatever reason they want to continue using Redis for the foreseeable future, that is totally welcome and totally supported. OCI Cache is going to be a two-engine service, a Valkey engine that we discussed or announced today, along with the existing Redis cluster. Both will coexist, and customers can pick and choose whichever one they want. Thanks.
Oh, thank you very much, Rashmi. I forgot to mention that there. So one of the another values of OCI Cache is that we really focus on resiliency of your application. So when you're creating a cluster, and that screen that I showed you where you pick the number of nodes or shards, we ensure that your nodes are split across domains. So if you're in a multi-availability domain region, we will split your nodes across multiple availability domains. So you will never be in a situation where all the primary and the replicas are in the same AD, and if it goes down, you lose your entire cluster. No. And if you're running a sharded cluster, what we do is we ensure that all the nodes within the shard are not on the same domain. And we also try to split the shards across domains as possible. We try to split them across domains. So that increases your overall Redis or Valkey cluster resiliency, and of course, increases your application resiliency as well. Go ahead, Rashmi.
Yeah, thank you, Dimitri, and thank you, Katie, for all the information and clarifications. So like Dimitri was mentioning, we are a highly available service, leveraging the multi-AD and multiple fault domains within a region. We scale without any downtime and hence provide lightning fast responses to your end users, making it a better user experience. With that, here are some resources, and this will be shared, so you will have a link to these resources as well for the service. So just log into your OCI tenancies and get started with using OCI Cache, either with Valkey or with Redis. Over to you, Olivia.
Thanks, Rashmi and Dimitri. Awesome session. And this page, just some resources to learn more. There's Oracle University, there's live labs if you want to get some hands-on experience. And then next slide, please. In addition to Day One and Beyond, we do have our personal training program, which is more one-on-one customized Oracle Cloud training. We also do have live labs, which is also one-on-one sessions, so more hands-on experience there. And there also is Code Innovate. So this is a 5 half-day online event where Oracle engineers would help you co-develop a use case. So if you want to explore some of those different programs, we do have the email at the bottom of the slide. And then lastly, next slide, please. We do have other series as part of our Day One and Beyond. So we have analytics, we have hands-on, we have cloud native, cloud security, and did you know? So please feel free to explore those. And then lastly, our next session will be disaster recovery and OCI on April 1st at 10 a.m. Pacific. So we hope to see you all then. And yeah, thanks everyone for joining.